Hello everyone, this is Mr. Appel, and today we're going to really get into the meat of pre-calc. We're going to really get started here, and we're going to look at graphs and using your graphing calculator to analyze functions and kind of go next level with some functions that you've already seen before and get you hopefully much more comfortable with the graphing calculator. So let's get started. For one, just kind of an overview here. What we're looking at when you're using the calculator, finding a good window, and this is something we touched on a little bit earlier in the year, but it is a skill that you're going to have to develop to find a good window in your calculator. The standard -10 to 10 on the x and y axis isn't always appropriate. Sometimes it's fine, sometimes it's not very useful, so we're going to look at that. And there's some window notation that you're going to need to get used to. This is probably new for you. And it's this bracket notation that you see right here. And there's three numbers in each set of brackets: the x min, the x max, and then the x scale, which is what you're going up by on each tick mark, each hash mark on the x-axis, and then the same for the y's. So it's -10 to 10 by 1s, by, and so this is now the y-axis, -10 to 10 by 1s on the y. So that's the standard window, but you're going to use this notation for windows. You should also be able to use your calculator to find a table of values, so we'll review that quickly or introduce it if you've never seen it before in the calculator. Look at the window and using your table set for tables as well. Okay, so let's get into an example. So here's a function, y equals x cubed minus 4x. Now, in Algebra 1, or even Algebra 2, if you were going to try to sketch a graph of this function, you would probably pick a few x values and evaluate them. So you might say, all right, let me try -3. So I'd plug that in, and that's -27. Minus 4 times -3, so minus a negative is plus, so that's plus 12, so we'd get a -15. And maybe I'd pick a couple others. I'd pick x equals 0. Well, that's 0 minus 0 is 0. And if you have trouble with this, you should be trying it because you will need to be able to do it. Maybe I'd try like x equals 2, so 2 cubed is 8, minus 4 times 2, which is 8, so that's 0. And I might sketch plot a couple of points, and -3, -15 is way down there somewhere. Maybe I'd pick one more, something like that. Well, that's 125 minus 20, so that's 105. So it's way, way off my graph. So I might expect this graph to be doing something like that. Not really sure. But the calculator is going to help make this process a lot easier. Okay, so we're going to look at how to do that. So with the graphing calculator, if I put x cubed minus 4x, which I've done here, you can ignore this. By the way, this is a good little calculator trick. If you have two different functions that you're sort of looking at and you don't want to keep retyping one and then the other, you can have them both in the calculator like they have here, and you can just turn the display off on one of them. So in a moment, we're going to be looking at this second equation, but I want it turned off right now. So I just go to the equal sign and I press enter once. See, that means the equal sign is lit up. Now it's on. Press enter again. That turns it off. So that way I'll be able to, without having to keep retyping, turn any function off and on. So you can have like 5 in there, and you may not want to see all at the same time. So that's just a convenient little trick. So let's take a look at the table that this would generate. So rather than having to do what we were just doing by hand, I'm going to do a table. So first I'm going to do the table set. I'm going to set up my table. So second window, you see it says TBL SET, that's table set. So you can choose what you want to start the x values. I'm going to start it at, let's say, -5. And I want to go, that's an up arrow, so that's up table. So we're going to go up by 1s. There are times when you might want to go up by 0.5s or by 10s or whatever. And then you can go ahead and make your table once you've done that. So second graph you see is table. And I get some values. And this is helpful to kind of sometimes pick a window if you're about to do a graph. I see there's an x-intercept, -2, 0. There's another one at 0, 0. And another one at 2, 0. So I can see my intercepts right there. And I see that they're all at x values between -2 and 2. So maybe the standard window is going to work just fine for this. So let me just zoom 6 to graph this at the standard window. And sure enough, that looks pretty good. Okay. Now let's look at another function. Let's look at the function y equals x cubed minus 7x squared plus 28. So go ahead and put that in your graphing calculator. I'm going to put it in mine. So I'm just going to turn off the first one, and then turn on that new one, which is x cubed minus 7x squared plus 28. And I'm going to go ahead and graph it using the standard window. And that is horrible. Why is this bad? Well, I can see where it crosses the x. That's good. I can't see the y-intercept, and I can't see where it turns from going up to going down. There are turns in this graph, and I can't see them. So that's a bad window. So when I tried, here's the standard, here's that window notation. When I tried negative 10 to 10 on both, didn't work very well. That was a bad window. So what do I need to do? Well, let's try a different window. Let's try maybe focusing in from negative 5 to 5 on the x-axis, but going a little bigger on the y values. So you see I've changed that here. So now my graph is still bad. Notice what's wrong with this one. I can't see this x-intercept out here. I see that the graph is starting to turn to go back up, but I can't see the x-intercept, so that's bad. I can see this turning point, but I can't see this turning point, so that's a bad window as well. So let's look at another window. So I would go back to my window and change it to this. This is a good-looking graph, right? I can see all three x-intercepts. I can see the two turning points. I get a nice clear picture. So this is the notation. So if I ask you to show me the window you used, this is how you would write it down. Okay, now let's explore this graph, this function a little further. I'm going to stick with that same function, so you don't need to start a new one. Now from this, I want to determine some things. The domain. Well, remember, domain is the possible x values. Are there any restrictions on the x values? And the answer is no. This can go, you can put any x value into that function. The graph, you can see it goes to the left forever, it goes to the right forever. So that's going to be all real numbers, or negative infinity to infinity. The range, that's up and down, remember, output values. So does this go down forever? Yes, it does. Does it go up forever? Yes, it does. So that range is also negative infinity to infinity. The x-intercepts. So I want to show you how you can calculate these on your graphing calculator. So the x-intercepts, remember, are where y equals 0. So the easiest way to do that is to graph the equation. I'm just going to clear out that first one and graph the function y equals 0. Remember, we used this trick earlier, and this is a really easy way to do it. And I want to see where the line y equals 0 intersects our function. We know it's going to happen in 3 places, but I need to know exactly where. So if we look at that graph, okay, I want to find the intersection of the two. So we're going to do second, calc, intersect, which is 5. And all you have to do, because there's only 2 functions here, is enter for the first 2 curves. And then the guess, you're just going to put your cursor so that it's kind of close to where you think it is. So I'm going to try and find this one. And there it is. So that x-intercept is at about negative 1.8 or so. I can do that again. Second calc, intersect, enter. Now I need to move my cursor to the right. Now because I picked a bad window here, in fact, I'm going against what I just said. So let me back up a step here and put in a good window here. So negative 5 to 10 by 1s. Should have done that before. So negative 5 to 10 by 1s, and then, whoops, and then negative 50 to 50 by 10s. That was our good graph. So negative 50 to 50 by 10s. This is going to be our nice graph so we can see what's going on. So there I got my nice graph. So now it's going to be a little easier. So now when I do second calc to find the second intersection, I'm going to do enter for the first curve, enter for the second curve, and my guess is right there. So press enter, and my second intersection is around 2.49, about 2.5. To find the third one, second calc, intersect, enter, and then just move my guess over to that third x-intercept. This is why a good window is helpful, right? So it's really easy to follow that cursor over there. And there's my intersection, which is around 6.3. So that's how you can use your calculator to find the x-intercepts. The y-intercept is when x equals 0, so it's 0 something. I'm going to show you a really cool little trick to have the calculator tell you what that y-intercept is when x is 0. When you're on this graph here, just looking at a function, if you just type in a number, so I want to see what happens when x is 0, you just type in a number and look what happens. It tells me x equals 0 for this function, and if I press enter, it actually shows me the exact coordinates there. Okay, so that's pretty convenient. So x equals 0, y equals 28, so I can determine that my y-intercept is 28 pretty quickly and easily. So that's a kind of a convenient little trick. If you wanted to see what the value of this graph is when x is 4, you could just literally type in the number 4 and press enter, and it tells you when x is 4, y is negative 20. Kind of a convenient little trick. Okay, moving right along. One more thing, let's just look at a graph now and see what kinds of questions we can answer about it. First thing you may notice, this is a graph like no other you've probably seen. It is discontinuous. What I mean by discontinuous is if you put your pen on the graph and follow along, there is a hole in it, and that hole is right here. That's what it means to be discontinuous, is it has a hole. It has an x value in the middle of it somewhere that doesn't work, that blows up. So for your domain, we need to exclude that. So my domain, which is my x values, so I'm starting at negative 6, but not including it, but I have to exclude 3. So I'm going to go negative 6 to 3, and then 3 to infinity, using parentheses because I'm not including those numbers. My range, so my range, remember, is the possible y value. So the lowest y value I see is right here, so negative 4, and it does look like it touches negative 4, so I'll include that. Now there's no hole in the range because even though there's a hole there, I can get to that number 4. I can have 4 as an output here. So any values from negative 4 up to positive 5 are included in that range. Notice I put a paren on the 5 because it doesn't actually get to 5. Okay, so that's the range for that function. The x-intercepts I'm going to look at just by getting this off the graph. They're right there at negative 4 and negative 1. So I'm just going to read those off of my graph. And the y-intercept, I know my graph's a little bit messy, but it's right there, and that's at 1. And if I ask you to just read some other data off this graph, when what's y when x is 4, I would just go over to x equals 4, and I'd be able to tell you it is 4. Now, what if I said what is y when x is 3? Well, when x is 3, the function is not defined at x equals 3. It's got a hole, so you would say undefined. That's all for today. Thanks.